Space debris, also known as space junk or orbital debris, refers to non-functional, human-made objects in orbit around Earth. These objects include defunct satellites, spent rocket stages, fragments from collisions and explosions, and other discarded remnants from space missions. The increasing amount of space debris poses a significant threat to operational satellites and can potentially impact future space activities. Key aspects of space debris and its threat to satellites include: formation of space debris. Space debris is primarily generated through a variety of sources, including satellite breakup. Malfunctions, collisions, or explosions of satellites can produce numerous fragments. Rocket stages. Discarded rocket stages left in orbit contribute to space debris. Mission-related debris. Objects such as lens covers, thermal blankets, and other equipment released during space missions. Orbital dynamics. Space debris orbits Earth at various altitudes and inclinations. The debris can travel at high velocities, posing a collision risk to operational satellites and other space assets. Collision risk and satellite threat. The primary threat posed by space debris is the risk of collisions with operational satellites or other spacecraft. Even small fragments can cause significant damage due to their high velocities. Kessler syndrome. The Kessler syndrome is a scenario in which the density of space debris in low Earth orbit, LEO, becomes so high that collisions between debris objects generate even more fragments. This cascade effect could lead to a self-sustaining increase in debris, making certain regions of space increasingly hazardous. Mitigation measures. Efforts are underway to mitigate the generation of space debris and reduce collision risks. This includes guidelines for spacecraft disposal at the end of their missions, limiting the creation of new debris. Some satellites are equipped with propulsion systems to perform controlled deorbit maneuvers. International cooperation. Addressing the challenges of space debris requires international cooperation. Organizations such as the United Nations Office for Outer Space Affairs, UNOOSA, and the Interagency Space Debris Coordination Committee, IADC, work to establish guidelines and best practices for space activities. Space traffic management. As the number of satellites and space activities increases, effective space traffic management becomes essential. This involves monitoring the positions of satellites and debris, predicting potential collisions, and coordinating avoidance maneuvers when necessary. Long-term solutions. Long-term solutions to address space debris include the development of active debris removal technologies, which involve capturing or deorbiting defunct satellites or fragments to reduce the overall debris population. Space agencies, private companies, and international organizations are actively engaged in research and initiatives to address the challenges posed by space debris. The goal is to ensure the sustainability of space activities and prevent the escalation of debris-related risks to satellites and future space missions.